This is a question on Malus law. So let us first look at the question. So we have a plane polarized light beam, plane polarized light is incident on a polarizer with the direction of E0 parallel to the direction of the transmission axis. Through what angle? Through what angle should the disc be rotated, or the polarizing disc, that means the polarizer, should the polarizer be rotated through what angle should the polarizer be rotated so that the intensity in the transmitted beam is reduced by a factor of 3, 5 and 10. So this is a question based on Malus law. Here E0 is the direction of E0 here means the polarization direction of the input light beam, and transmission axis is for the polarizer. So let us draw the situation. So we have incoming electric field, and then there is a polarizer. This is polarized incoming field. So this is polarized light, and then we have a polarizer whose transmission axis is also parallel to this polarized light E0. So this is the situation. Now we want to rotate this polarizer. So we want to rotate the polarizer. So this is again the field, and we want to rotate the polarizer through some angle theta. So let us say that this is the angle through which it has been rotated. This is theta, and then the output intensity in this case, let us say this input intensity is I0 for the polarized light, and then this polarizer is there in which the transmission axis is making angle theta with respect to E0. So in this case, the output intensity is going to be I naught cos squared theta. This is Malus law. So we will use this Malus law to solve the question. So let us see what the question wants us to find out. So we want the output intensity to be reduced by a factor of 3. So for part A, so this is the output intensity. So and this ratio we want to be 1 over 3 because it is reduction by a factor of 3. So this is the ratio that we want. So from this we find out theta is cos inverse square root of 1 over 3, which comes out to be roughly 54.7 degrees. Similarly, we will solve for the other parts. It is just different ratios of the intensities. So in this one, we want the ratio to be 1 over 5 because it is reduction by a factor of 5. So this gives this is roughly 63.4 degrees. Finally, the last part. So this is the solution to the problem. In this problem, we were supposed to use Malus law and find out the angle by which we should rotate the polarizer so that the output intensity is reduced by certain factors, namely 3, 5 and 10 in this case. So the takeaway from this question has been the use of Malus law. So just to repeat, Malus law gives us the output intensity after a polarizer is placed, given that in input we have a polarized light. So this is input polarized light with intensity I naught, and this is the output after the polarizer, and this is the output intensity, which is I naught cos squared theta, theta being the angle between the transmission axis of the polarizer and the input polarization direction. So this solves the question.